Hello my viewer, it is an honor having you on board. This is Dixon from MathsWiz, where we teach mathematics and mathematical sciences. Please join me for this lesson, learn, understand and enjoy maths with me. If you are new to our channel, please remember to subscribe to be our student and get our future lessons immediately they are released. Hello and welcome to our first lesson in the series matrices. In this lesson we are going to learn how to calculate determinants of 3x3 matrices. Our first method is the sarrus loop method, whereby we are going to consider 3x3 matrix A as given. To calculate the determinant, we are going to follow the following steps. Step number 1, we construct a 5x3 array by writing all the elements of the given 3x3 matrix and then repeating the first two rows. With that I mean the matrix that is on the screen. Step number 2, we consider the 6 diagonals of the 5x3 array we have constructed. That is diagonal 1, 2, 3, diagonal 4, 5th diagonal and the 6th diagonal. In the 6 diagonals that we have created, we are going to calculate the products, which will be given by, for 1 we have A11 multiplied by A22 multiplied by A33. Diagonal 2 will give us A21 multiplied by A32 multiplied by A13, whereas diagonal 3 will give us A13 multiplied by A12 multiplied by A23, whereas diagonal 4, 5 and 6 will give us A21 multiplied by A12 multiplied by A33. 5 will give A11 multiplied by A32 multiplied by A23, whereas diagonal 6 will give us A31 multiplied by A22 multiplied by A13. In step 3, we calculate the determinant as follows. Determinant of A is equals to the products along 1, 2 and 3. We subtract the products along 4 plus 5 plus 6. Having learned that, we can look at one of the examples. Our example 1 in the category is the matrix A, 8, 9, 1, 5, 6, 7, 2, 3, 4. The first thing we are going to do is we write the 5x3 array, and we are going to have 8, 9, 1, 5, 6, 7, 2, 3, 4. We repeat row number 1 and row number 2, that is 8, 9, 1 and 5, 6, 7. We now consider the products along each of the rows. Our rows are row number 1, row number 2, row number 3, whereas on the other set we have row number 4, row number 5 and row number 6, which implies that our determinant of A is equals to products of row 1 plus row 2 plus row 3, that is 297 plus 531 plus 864 minus the second set, and second set will give us 594 plus 837 plus the last values 261. The first set of diagonals will add up to 333. The second set will add up to 360. If we subtract the two values, we get negative 27. Our second method is the basket weaver method, and if we consider again the matrix A, the first step is we construct a 3x5 array by writing the matrix A and then repeating the first two columns. With that I mean, in the next step we are going to identify the 6 diagonals, diagonal 1, diagonal 2 and diagonal 3. On the other set of diagonals we have diagonal 4, diagonal 5 and diagonal 6. In the third step we calculate the determinant, whereby we have the determinant of our matrix A is equals to sum of the products of diagonals 1, 2 and 3. We subtract the sum of the products of the diagonals 4, 5 and 6. With that we have an example. A, 3 minus 2, 4, 3, 4, 1 and 2 minus 3 minus 5. We write the 3 by 5 array, that is 3 minus 2, 4, 3, 4, 1, 2 minus 3 minus 5. We repeat column 1 and column 2 to get 3, 3, 2, and minus 2, 4, minus 3. We now identify our 6 diagonals. Diagonal 1, second diagonal, and the third diagonal. The second set we have diagonal number 4, diagonal number 5, and diagonal number 6. Having done that, we now have our determinant of matrix A is equals to sum of the products of diagonals 1, 2, and 3, and that is 3 by 4 by minus 5 plus minus 2 by 1 by 2 plus the third diagonal is 4 by 3 by minus 3 minus the second set of the diagonals. We have 2 by 4 by 4 plus minus 3 multiplied by 1 multiplied by 3 plus minus 5 multiplied by 3 multiplied by minus 2, which will give us first set simplifies to minus 100 and second set simplifies to minus 53. Hence our determinant is equals to minus 153. Our third method of calculating determinant is by use of cofactor. In this case, we are going to first of all define the following. 1. If A is a square matrix, then the minor of element Aij, also called the ijth minor of A, is denoted by Mij and is defined as the determinant of the submatrix that remains when the ith row and the jth column are deleted. The number Cij, which is equals to minus 1 into brackets raised to I plus j multiplied by Mij, is called the cofactor of element Aij, or simply the ijth cofactor of A. In our calculations for determinant, we are going to be guided by the theorem. The determinant of a square matrix n by n can be computed by multiplying the elements in any row or any column by the cofactors associated to that row or column, and then adding the results of the products for each I between 1 to n and j between 1 to n. With that, I mean determinant of A is equals to A1j multiplied by C1j plus A2j multiplied by C2j plus all the way to A and j multiplied by C and j for cofactors expanded along the jth column, and the same determinant is equals to AI1 multiplied by CI1 plus AI2 multiplied by CI2 plus all the way up to AIN multiplied by CIN for an expansion along the ith row. The third example of the lesson is we're going to determine determinant of matrix A, that is 1, 2, 3, 2, 4, 5, 3, 5, 6. And for this question, we are going to expand along a row. The thing we're going to do is we calculate a minus, and the minus we have M11 is equals to, we broke row number 1 and column number 1, and we are left with 4, 5, 5, 6, 4, 5, 5, 6, and for this matrix we determine its determinant, which is going to give us 24 minus 25, that is minus 1. For M12, we broke row number 1 and column number 2, and we are left with the 2, 3, 5, 6. We get the determinant, and you're going to get 12 minus 15, which is equals to minus 3. For M13, this means we broke row number 1 and column number 3, and we are going to be left with 2, 3, 4, 5, and the determinant will be equals to 10 minus 12, that is minus 2. We now determine the cofactors, where we have C11 is equals to minus 1 into I plus j multiplied by minus 1 is equals to minus 1. C12 is equals to minus I into 1 plus 2 multiplied by minus 3. This is equals to 3. And Ci3 is equals to minus 1 into 1 plus 3 multiplied by minus 2, and this is equals to minus 2. By definition, by the theorem above, we have determinant of A is therefore equals to 1 multiplied by minus 1 plus 2 into 3, 3 into minus 2, and this is equals to minus 1 plus 6 minus 6, which is equals to minus 1. In question number 4, we have A 2 4 1 0 minus 4 7 minus 2 1 3. We use cofactor method, but this time we expand along a column and we are going to have rowing. We start by calculating the minus, whereby we have m11 is equals to, we broke row number 1 and column number 1. We are left with minus 4 7 1 3, and this translates to minus 12 minus 7 minus 19. m21, this means we broke row number 1 and row number 2 and column number 1, and we are left with 4 1 1 3, and this translates to 12 minus 1, that is 11. m31 means that we broke row number 3 and again column number 1, and we are left with 4 minus 4 1 7. We get the determinant, and we have, this is 28 minus 4, which is equals to 32. We now calculate the cofactors. We have C11, this is equals to minus 1 raised to 2 multiplied by minus 19, which is equals to minus 19. C21, this is equals to minus 1 raised to 3 multiplied by 11, which is equals to minus 11. And we have C31, this is equals to minus 1 into 3 plus 1 multiplied by 32, and this is equals to 52, which implies that our determinant of A will therefore be equals to, we have a 2 multiplied by minus 19 plus 0 multiplied by minus 11 plus our last value is minus 2. We multiply this one by 32, and this reduces to minus 38 minus 64, which is equals to minus 102. Our fourth method is the Gauss elimination method. In this method, the idea behind it is the row operations, where we reduce the matrix either to upper or lower triangular matrix, and we say that a square matrix is said to be upper triangular matrix if all the entries below the main diagonal are 0. With that I mean, we have for square matrix A, this is the leading diagonal. If the values on this side, all of them are 0, and the values on the unshaded part, not all of them are equal to 0, then that is an upper triangular matrix. And it is a lower triangular matrix if we have the following, the same square matrix, and this is the leading diagonal. We are going to say that if these values, all of them are equal to 0, and now on this other side, the unshaded side, not all of them are equal to 0, then that is a lower triangular matrix. For us to reduce a matrix to either the upper triangular matrix or the lower triangular matrix, the following properties of a determinant are going to be applied. The property number 1 is determinant of matrix A is equals to the determinant of its transpose. Number 2, if 2 rows or 2 columns of A are identical, therefore we say that determinant of A is 0. Number 3, if matrix B is obtained by multiplying single row or single column of A by a number k, then we say that determinant of B is equals to k determinant A. Number 4, if all rows or all columns of A are multiplied by k to obtain matrix B, then determinant of B is equals to k raised to n determinant A. Number 4, if matrix B is obtained by interchanging 2 rows of matrix A, then determinant of A is equals to minus determinant. Number 4, if matrix B is obtained by adding multiples of one row or column of matrix A to another, then determinant of A is equal to determinant of B. And having considered all those properties, then we have the following conclusion, that if A is an upper triangular or lower triangular matrix, then the determinant of A is equals to product of members of the leading diagonal. Now, example number 5, find the determinant of matrix A, and we use the upper triangular matrix. Now, in using the upper triangular matrix, we are therefore expected to make minus 2 and 1 to be zeros. We are going to do that one by following the following procedure. This is row number 1, this is row number 2, and this is row number 3. Let row number 1 remain. Let row number 2 remain. Let row number 3 be equals to the current row number 3 we add to row number 2. We are going to get first row remain, so we have 2, 4, 1. Second row remain, we have 2 minus 4, 7. Row number 2 plus row number 3, this gives us a 0 here. 4 plus 1 gives us a 5, and 1 plus 3 gives us a 4. This is our new row number 1, this is row number 2, and this is row number 3. Let the elements of row number 1 remain. We also retain the elements of row number 2, and we let our new row number 3 to be equals to row number 3 plus 5 over 4 row number 2. With that, we have 2, 4, 1. Row number 2 remains 0 minus 4, 7. The new row number 3 becomes 0 there. We have a 0 there. This becomes 51 over 4. Now notice that this one is now an upper triangular matrix, because on the leading diagonal all the elements below it are equals to 0. Therefore, we have determinant of A therefore becomes the product of elements in the leading diagonals, that is 2 multiplied by minus 4 multiplied by 51 over 4, and this is equals to minus 102. For this case, let us use low triangular matrix. Consider our matrix 0, 4, 5 minus 6, 5, 2, 3, 1. This is row number 1, row number 2, row number 3. Our aim this time is to make this value as 0, the value here value as 0, this value as 0. So what we're going to do is, the first thing is we are going to interchange row number 1, we interchange with row number 3. Our new matrix will be equals to 3, 1, 2 minus 6, 5, 2, 0, 4, 5. The new row 1 will be equals to the current row 1 plus row 2. Row 2 and row 3, we first of all retain them. And if we do so, 3 plus minus 6, that is equals to minus 3. 1 plus 5, that is equals to a 6. That gives me a 0. Then we have minus 6, 5, 2, then 0, 4, and 5. Now the next step now is we want to make these two to be a 0, and we can only do so by arguing the following. We retain row number 1, then row number 2, the new row number 2 is equals to current row number 2 minus 2 divided by 5 of row 3. And that would give row 1 remains minus 3, 6, 0. Row 2 is minus 6, 17 over 5. There we now have a 0. Then 0, 4, and 5. The next step is we write this 6 to be a 0. And for us to do so, we are going to argue row 1 would therefore be equals to the current row 1 means minus 30 over 17 row 2. This we get 129 over 70. This is a 0. This is a 0. Row 2 remains minus 6. 17 over 5. This is a 0. Row 3 we have this is 0. This is a 4, and this is a 5. And now we have succeeded to write it as a lower triangular matrix. Since we did a low interchange of the matrix A, then it will mean that we are going to use the property that determinant of the new matrix B is therefore equals to minus determinant of matrix A. If we consider this one to be our matrix B, it will therefore mean that determinant of our matrix B is equals to minus determinant of A, and that is equals to minus 129 over 17 multiplied by 17 over 5 multiplied by 5, and this one is equals to minus 129. This is Dixon again from Maths Wiz. It is my hope that you have learned, understood, and enjoyed the lesson. Please remember to subscribe to our channel and give us your feedback from the lesson. Thank you for your watching.